Hi everyone, this is the Lab 6 walkthrough covering DHCP and NAT. So this Lab 6, one of the biggest differences is there's a loopback interface on the core. Make sure you cover that. I've updated the VLANs to say SVIs, so SVI 30, 40, and of course still have the first usable, last usable. We're changing some things around. We have access controls, NTP, but now DHCP and NAT. Everything else is pretty much the same with the exception of a few changes for the end devices and access control lists. But the layer 3 switching, the configure the switches, the routers, that's all the same. So I'm just going to skip all of that and go right down to access control list. So we are going to create a standard named access list for NAT. We are not going to implement that extended ACL. That's how you configure it. And you just go ahead and configure this name, have the permit statement, and then permit the rest of the end user networks. So all of these networks right here, make sure all those are permitted through. And we'll just allow the one range through. So we want to go to our edge. The reason why it's on the edge, because that's the edge of our network. So IP access list standard, many to one NAT, and then our permit of our network ID, and our wildcard mask. So right now I'm only permitting the sales network, but for the lab you have to permit all networks. And for the next ones you just type in permit, then the next IP address ranges. So that is that. Let's put the host name so we know where we are. There we go. So that is the access control list for a NAT. Configure NTP, configure DHCP. Here we go. DHCP. What DHCP is it will dynamically assign an IP address to a device. And that could be an end device, a computer, a printer, an access point, or it could actually be a router or a network infrastructure device. We do not want to use DHCP for servers or network infrastructure devices like routers and switches. They need to be statically assigned. And the reason why is because they are pretty important. They need to have the same IP address because most things are mapped to them. So you want to make sure that those things have static addresses because they're pretty important. So we are going to configure the core router to act as a DHCP server for the HQ and branch end user networks. Once again, that's for sales, HR, math, and IT. So we need to configure an IP pool. Now, a pool is just the configuration for that DHCP name. And what it basically says is here's all the options that you can set. Now, options are just settings that you can push out to devices. We're going to push out the network range, so IP address and subnet mask, the default router, so the gateway, and the DNS server, because we want to access that talktick.com website. So we go to our core. Put that in there. And it's pretty simple, just IP DHCP. Then you have your pool name that you want to have. You want to name it sales. Now we're going to match the pool name with the VLAN name. Now you don't have to do that, but it's good to have it organized so that way everything flows very smoothly and it's easy to troubleshoot things. The first thing we're going to do is configure the network range. So what IP addresses can I have to work with? It's just like with OSPF, it's the network command. And then you put in the network ID and the subnet mask. And then the default router, which is our gateway. And then last but not least, our DNS server. Now if we do a question mark, we can see all the options that we can set. Now there's not very many options here, but we have this option right here that we can go ahead and start putting in option numbers for more settings that we can push out to end devices. Do show run, and we see our pool right here. Now with this configuration, it basically says start with this IP address of .0 and to start assigning IP addresses. So give .1, .2, .3, all the way to the end. Give them out to everybody. We need to start excluding IP addresses so that way Dhcp does not hand out every single IP address, including IP addresses that are already in use by the gateway. So we're going to set up our exclude range next. Exit out. And so you'd set up a pool for IT, math, and HR as well. Now to set up an exclude range, so you're basically telling DHCP, do not hand out IP addresses within this range. And we're going to do the very first 50. So here's the exclude range. IP DHCP and exclude addresses. Now exclude addresses is kind of nice. You start with the lowest IP address, so where do you want to start from? We want to start with 0.0. And what's the high IP address? We want to go with 1.2.16.0.50. We want to exclude the first 50. That's it. Now let's say that we want to exclude more within that range. Well, you just type in the same command and you type in whatever you want the starting point to be and wherever you want the end point to be. So if we wanted to exclude more, let's just say 100 to 150, we could go ahead and do this. Now, IP addresses 51 through 99 would be used. Then we'd have another block of 100 through 150, which would be unused and which would be reserved for static devices like printers, for example. But we don't need to do that today. And so you do an exclude range for every single VLAN. So that's sales, HR, math, and IT. Now, IT is a little bit weird because it says 64 through 90, and that's because network ID starts at 64. Now we need to configure our IP helper address. And we have to set this up on every single network that we want to have DHCP on. Now what the IP helper address command does is it takes the layer 2 DHCP protocol packet and it will encapsulate it in a layer 3 packet so that way it can get routed across the network. And so that way we can have a central server and located in one spot and all networks can go to that one server. Otherwise, if we didn't have this command, every single network would require its own DHCP server. Now, it's not such a big deal within our lab, but if you go to a huge scale and we have more layer 3 switches, we have more routers in there, the next thing you know, you have a DHCP server everywhere, and it becomes a headache to try to manage that. Whereas with the IP helper address, we can now have one DHCP server, maybe two for redundancy, and only have to make changes in a few locations versus many locations. So the IP helper address goes on every single network interface that we configure for end user devices. So the core is not one of them, but we have two places, the HQ router and the layer 3 switch. So I'm going to configure that real quick. Oops, I forgot the encapsulation command. And I need to configure the upstream as well. That'd be 00, okay. So I need to add in the IP helper address. I'm just going to go 2.2.2. Do show run. Oops, I did it on the wrong interface. Oh no. Now let's try it. That's why it's good to verify your configurations. There we go. Now it'll work. So you're probably wondering, what is this 222 address? Well, that's going to be the loopback on the core. But first, let's configure some interfaces. Let's see what I got for my setup. And it looks good. Oh, I forgot one spot. There we go. All right, I can go to the core. Now, I'm not sure if this is the right IP addresses on these interfaces. I'm just tossing them in real quick. See our configuration. You see our loopback address. You see our OSPF configuration. We want to go ahead and do this real quick. We want to clean up this part right here. Oops. There we go. And so HQ should see a route to the 2 network. Yay, and we see it. All right. I think we're done with this. All right. Now it's on to the switches. So we're just going to do the basic minimum to get Dhcp to work. I believe it was fast Ethernet 01. Yep, fast Ethernet 01. Okay. Should hopefully. Oh, whoops. Wrong port. There we go. And now all we have to do is click on this and see if it works. And we got an IP address. Yay. So you remember how we excluded the first 50, so 51 should be your first starting point. But all these settings that we used to manually have to configure are now configured for us, which is pretty cool. So that is DHCP. Now NAT. So What NAT is just the process of taking an IP address and then converting it to another IP address. Now, this is normally used for accessing the internet. So on a normal network, you're going to have privatized, non-routable across the internet IP addresses. So 10.x networks, 172.16 networks, 192.168 networks. Hopefully not in business, you're going to have that, but you get the drift. All the private addresses are not routable across the internet. So we have to actually go buy a publicly routable IP address. Now, it can get expensive, so you buy as few as possible. Usually it's just one IP address. Then you NAT from your private inside network to your public outside network. And that's what happens on your home network as well. So there's two types of NATs that are most commonly used. There's a static one-to-one, which means one private address is NATed to the same public IP address every single time. Now, think of a use case of being like web servers. So basically anything where an external network like the internet needs to access a particular device on your internal network. And then we have many-to-one, also known as port address translation or PAT. Now that is the process where you have many devices all getting added to the same IP address. That's what happens when your private IP space on your internal network is NATed to your public IP address. And the steps for that are pretty simple. First, we need to define what interfaces are going to be on the outside, what interfaces are going to be on the inside. So we go to our edge router, so that's where we're going to do NAT. And we configure our inside and outsides. So gig 00, that is our outside because it is the one connected to the ISP. So VNet outside. And then we go to our inside and gig 01. We type in IPNet inside. Do show run. You see we have our inside and our outside. Now, normally you'd have your IP addresses configured on these interfaces. And of course, not shut down. Now we're going to configure the static one-to-one NAT first. Static one-to-ones are the easiest to configure because all you do, you type in the commands IPNet. What traffic are you looking for? You're looking for any traffic coming from the inside interface. Source, it's going to be a static source of 192.168.99.254, which is our management IP address for our HQS1. And then we're going to NAT it to this IP address. Now, if you notice, this IP address is nowhere on our network. That's the great thing with NAT. It does not care which IP address you give it. It'll go ahead and assign it the IP address. So for that, IPNet inside, source, static. Then who are we going to be? What traffic are we looking for? We're looking for any traffic from this IP address. Now, what do we want to translate it to? 1.2.3.4. If you notice the name, global IP address, that means it's a routable IP address. Now it's time for the many-to-one NAT. So many-to-one, we have to create an access list, and luckily we did that earlier. So do show run, we'll see that access list right here. So IPNet inside, that's the interface that we're looking for any source traffic. Source, we're going to take it from a list. The list means like ACL. And so many-to-one NAT, that's the ACL that I created. So basically anything that has a permit in here will get matched. So any traffic coming from the inside sourced interface that matches this ACL will get NATed. Anything that does not match it will not get NATed. And now we want to figure out what are we going to NAT to. So there's two ways we can go about it. We can do a pool which means many to many. So we can have many IP addresses going to a pool of many IP addresses, and many just means more than one. So 2, 3, or 5,000. It's your call. Now that is in use if you have huge networks, but most of the time you have small enough network under several thousand devices that one IP address can handle everything just fine. So we're going to go interface because we want to specify the outside interface as the IP address to use. And then of course it's gig 00. Let's move this over. And then overload. So what the overload command does is it just pats that interface for all the inside interfaces. So you have many internal IP addresses, all privatized IP addresses, being netted to one single publicly runnable IP address. And that's where the overload command comes in. So do show run. We'll see we have our IPNet outside, IPNet inside. We have our many-to-one NAT, also called a PAT, port address translation. We have our static one-to-one NAT, and we have our access list for our PAT. And now if I had the network configured with all the IP addresses on it, we could actually see NAT taking place and how the packets would get changed from one IP address on the internal network to an outside IP address. So that is it for NAT and PAT. Let me know if you have any questions.